Hi, my name is Mohamad Zainudin. My metric number DA 2056. We are from Group 3 in Section 2 in Power Electronics. So I'm as the first presenter of our group. I would like to talk about the introduction first. So as we know, an inverter is a device that converts direct current, which is DC, to alternating current, also known as AC. An inverter's design affect the input voltage, output voltage, and frequency, and then the total power handling. The power is given by the DC source, not the inverter, which does not generate any energy. In order to realize the three-phase output from a circuit employing DC as the input voltage, a three-phase inverter has to be used. The inverter is built as a power electronic inverter based on certain requirements using an appropriate simulation tool and are able to solve the issue or problem encountered. In this study, the three-phase inverter and its functional operation are being analyzed for students to solve an open-end problem. So that's all from me. I will pass another section to my group member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aliff Nadzmi bin Ahmad Kamal DE 200132. I will continue by present the methodology of this project. So there is attachment of the flowchart that been used for the whole project to design the three-phase inverter. So our group begin with the inverter design. So in this part, we will have a component specification that we will be used for the whole experiment or design. So the value of resistance, voltage source, and also the inductance will be selected and determined before we proceed with the next steps. So for the next step, our group have chosen the PWM design as a switching scheme, and then we have a simulation and calculation that we will compare the final answer both of them, and we need to tally the each answer and before we proceed with the options. So there is two options. If the verification of total harmonic distortion is less than 7%, we will proceed with the analysis and discussion of the result. So we will analyze the output voltage produced by the design itself, and also the design and the component, also the value that affected the result. So if the verification is no, which is the THD is bigger than 7%, we will go back to the inverter design and we will do some adjustment of the value for the component, and the process will be repeated until the desired output is achieved. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Zarawi, and my metric number is DE200121. So now I will present about the three-phase inverter, which is PWM. As you can see, here this is the PWM generator, and here this is three-phase inverter. In this case, the PWM generator will produce the sine waveform output to the three-phase inverter. In produce the sine waveform, we use the R sine wave as the source, Y sine wave, and B sine wave, and also we use the sawtooth generator. As we can see here, this is the graph form for this is for the R sine wave, this is for the Y sine wave, and this is for the B sine wave. And for this one, this is the sawtooth generator sine wave. Okay. After that, in the PWM generator, we use the NOT for the logical operator, and this is the output waveform that we can get from the PWM generator. As you can see here, this is the Soto-like waveform, and this is the sine waveform, and also this is the waveform that we can get from the PWM generator. Okay, from the PWM generator, the input will go into the three-phase inverter. As we can see here, the S1, S3 and the S5 is from the PWM generator, which is S1 is from R sine wave, S3 which is from the Y sine wave, and for the S5 is from B sine wave. The S4, S6 and S2 also from the PWM generator, which is S4 is from the R sine wave, S6 is from the Y sine wave, and the S2 is from the B sine wave. In this simulation, for the three-phase inverter, we use MOSFET, and for the RL, we use for the resistance or R, we use 14 ohm, and for the inductance, we use 0.3 millihenry. As the result, the waveform, we can get the waveform like this. So for the total harmonic distortion, for the three-phase inverter, we will get the this is the waveform for the three-phase inverter, and for the total harmonic distortion, we will get 40.36%, and okay, this is for the PWM generator. We will get the THD or total harmonic distortion 0.07%, which is less than 1%. And for the output from the PWM generator, we will get total harmonic distortion equal to 0.08%. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Mohamad Rashidin bin Ramlee. My meeting number DE200073. So firstly, I want to explain the manual calculation that we calculate to match the simulation results. First thing is find the VDC using VL to IMAX formula and get the value 569.87 volt. Next, we need to find the output current and then get 29.64 ampere, and using the basic formula as shown in the slide here. So next, for FC, first we need to calculate the PWM period. Then to find output power, use the basic formula to get the value, and the value is 50. And lastly, for this manual calculation is to find the value of capacitor. So for the result and discussion part, we get through really quick. First, in this MATLAB simulation software, we need to create the block diagram referring to the asked question. For your information, this inverter system need to get the value of THD below than 7%, and the value of voltage is around 415 volts, based on the value that we use in the simulation. Based on our result, we discuss The value of THD must get below than 7% if we decrease the value of filters that we use in this experiment. As we know, filters for the systems consist resistor and inductance. To get the THD less than 7%, all we need to do is to decrease the value of the inductor in the filters. That's all from me for explanation of manual calculation, result and discussion. Thank you very much.
Assalamualaikum, my name is M.Rifqi Aiman Azizan. My metric number is DE200115. For this last part, which is a conclusion. As we all know that the function of three-phase inverter is to convert the DC sources to the AC sources as the output. And this structure of three-phase inverter consists of a three-phase inverter switches that will be connected to each all three load terminals. And this type of inverter widely used in many applications. For example, it will be used in a solar hybrid system for the smart grid. The function of three-phase inverter in this system of solar hybrid is to reduce the leakage current in solar inverter structure. So, to solve this problem that related to it, the galvanized isolated system will be added between the AC grid and the PV array to make the leakage current going to the ground. In addition, there are some advantage of three-phase inverter compared to the single-phase inverter, which is it can transmit more power and efficiency during the produce of output voltage. That's all from us. Thank you.